Morning, ladies and gentlemen. What we're going to do is we're going to try and do a quick run through of the activity today to see if I can A, get it under 20 minutes, and B, be efficient about it. This is about the third time that I've tried to do this video, and I've had to go back and fix some stuff. So let's see how we're doing so far. What you're going to do is always go to your Google Classroom. Today we're going to do forming a precipitate, which is basically the end result of the chemical reaction, right? And what I'm having you do is let me see. Okay. What I'm having you do is look at a screen that's not even functioning right now. So let me see why it's not working. Let me go to another class. Good. There it is. All right. So forming a precipitate, here's your summary, your objective. Remember, if the aliens ever attack, that's exactly what you are going to tell them. All right. You'll be able to explain that a chemical reaction took place. The reactants interact, bonds between certain atoms and the reactants are broken. They are rearranged. The new bonds between the atoms are formed to make the products, and be able to explain that the definition applies to the production of a solid called a precipitate. All right, this is the video primer that they don't want me to send you, and this is the multimedia that goes along with the form. But the form itself, the actual activity is self-explanatory. Do you need the multimedia? Not really. But as always, it says put your last name, your first name in there, your email. The reason being is so that it sends it to you. My first class that I teach is 898. Notice that it's only 13. All right. This one basically tells you about what you guys are learning about today, and it's the understanding of what I just said to you, right? So the first one is it has a video of sodium carbonate and magnesium sulfate solutions reacting to each other. So let's take a look at that.
Here we have two clear, colorless solutions. The solution on the left is sodium carbonate. It is dissolved in water. Be careful, this isn't sodium bicarbonate, which is baking soda, although it is closely related. On the right, we have magnesium sulfate, also dissolved in water. The solutions will be mixed together and will look for signs of a chemical reaction. When the two clear, colorless solutions are mixed, a white solid forms. This solid is called a precipitate.
Yep.
Let's watch one more time as the two clear, colorless liquids combine and a chemical reaction occurs. A white solid forms. This solid is called a precipitate. In this case, the precipitate is magnesium carbonate.
That's pretty cool. All right. So in the video, when you add the two of them together, you get the add a magnesium sulfate. The sodium carbonate is an ingredient in many powdery detergents, and magnesium sulfate is Epsom salt. So basically detergent and Epsom salts, and you're going to get a white solid. Each solution was clear and colorless, but when they are combined, a white solid was formed. The solid is called a precipitate and does not dissolve in the solution. The formation of a precipitate is evidence or a clue that a chemical reaction occurred. That was the question that we asked over here. How do you know when a chemical reaction occurred? Let's go back to it. Okay. Let's take a look at this.
Here we have two solutions. The first one is calcium chloride, which is dissolved in water, and the second one is sodium bicarbonate, which is also dissolved in water. Calcium chloride is CaCl2, and sodium bicarbonate is NaHCO3. The sodium bicarbonate solution is added to the calcium chloride solution. Do you see a reaction? You'll notice many bubbles are forming. These bubbles are carbon dioxide gas. Before the reaction occurred, we had two clear and colorless solutions. Now we have a white liquid and we have a gas. These two changes are evidence of a reaction. We have a solid that is making this a cloudy white solution, and we have a gas where before we only had liquids. The products of this reaction have different properties than the reactants, which provides the evidence that a reaction has occurred.
Okay, so going back to it, the color change, the gas, and the solid, these are all evidences of a chemical reaction taking place. So what did you notice when the solutions of calcium chloride, which is rock salt, and sodium bicarbonate, which is baking soda, were combined? Gas produced, and a milky white liquid. It became a milky white liquid. What evidence did you notice of a chemical reaction? Gas produced, and a color change. All right. Now, again, when you do this and you get the grade for it, it's going to say all of them are wrong, but that's because I didn't write the answer key for it, and I don't have the answer key for it. All right, let's see if we were right. When we mix the thing together, the mixture bubbles, gas produced, and white particles of a solid form, so milky white liquid. All right, there's evidence that a chemical reaction took place because the liquids were both produced solid and a gas. These produces from the reactants. That's fantastic, okay? Look at the chemical equation for the reaction between calcium chloride solution and a sodium bicarbonate baking soda solution. Calcium chloride 2NaHCO3 makes calcium carbonate. 2 sodium chloride salt, table salt, 1 water, 1 carbon dioxide. So take a look at it. Calcium chloride is a white solid, is a type of salt that is commonly used in the winter on icy roads. Rock salt, like I said. For this reaction, it is dissolved in water to make a calcium chloride solution, so it's rock salt water. When a reactant is in solution, the water is usually not listed as a reactant, okay, because it's like not there. Which atoms make up a molecule of calcium chloride? So that's calcium. You want to go calcium and chlorine. Well, I can't do that, so I'm going to go chlorine. Chlorine. All right. I'll change that again. Calcium and chlorine. All right, and the formula for calcium chloride, NaClCl2, what does the little 2 mean? 2 molecules of chlorine. 2 chlorine atoms, I'm sorry, not 2 molecules of chlorine. The sodium bicarbonate, which is not nacho, that's sodium acetate. We learned that yesterday. This NaCO, okay? What is the big 2 molecules of what is it? Sodium baking soda. All right. For each element, start with the calcium, put it in, put 1 check in for each row. I'm going to make this a little shorter so I can do it, so I can cheat off it. Put 1 each row for the amount of element that are in 1 sodium bicarbonate. All right. So sodium bicarbonate, you got 0 calcium, 0 chlorine, 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. All right. So calcium carbonate is composed of calcium and chlorine. The 2 represents the 2 chlorine bonded to 1 calcium. 2 NaHCO3 means that in this equation, 2 molecules of sodium bicarbonate react with 1 molecule of calcium chloride. 1 molecule of sodium bicarbonate contains sodium, hydrogen, carbon, and 3 oxygen. Yes, we rock. We're halfway done, and we got 10 minutes to go. Let's see if we can do this. All right. What does the gas produce? Okay, I'm sorry. Let's focus on the products of the reaction. Calcium chloride, 2 sodium, sodium, hydrogen, carbon, oxygen, sodium bicarbonate, calcium carbonate, sodium chloride, water, and carbon dioxide. What is the gas produced by the reaction? That is carbon dioxide. Dioxide. All right. What other substances are formed as products of the reaction? Calcium carbonate, sodium chloride, and water. All right. Calcium carbonate is the solid precipitate that makes the solution white. Where does the calcium atom come from in the calcium carbonate? It comes from the calcium chloride. All right. Look at the equation to answer the questions. Put it in the. So basically, we're doing the same thing. So over on this side, how many calciums are over here? One. How many chlorines? One. Oh no, two. Two chlorines because there's two chlorines right here, right? 2 times chlorine, right? Sodiums. Let me see how many sodiums. We got 2 sodiums over here. We got 1, 2, 2 hydrogens. Yep, 2 hydrogens are over here. Carbons, we got 1, 2, 3, 4. 4 carbons over here. 1, 2, 3. 1, 2. No, that shouldn't be right. 1, 2. Yes, we have 2 carbons over here. And oxygens, we got 3, 4, 5, 6. 6 over here. Now, if you notice, if I go up to this is different than the other one because I forgot about this the 2 combo. I didn't think about that. So, you know, I screwed up. You know, I'm a terrible teacher. What can I tell you? Oh, wait a minute. They didn't ask for that. Okay, cool. Now look at the products things. All right. So I did the reactants. Oh, I did the products up here. And the reactants down here. Well, they're going to match out. So, you know, I'm really great at this stuff. All right. So calcium, let's see. We're doing the let me see. We did the reactants. The reactants are here, so we do the products down here. Okay. Same basic thing. Anyhow, they balance out. Okay. So that's 3, 4, 5, 6. No, I'm sorry. I'm looking at the wrong one. One carbon. 3, 4, 5, 6. 6 oxygen. 2 sodium. 2 chlorine. And 2 hydrogen. Now, if you look, oops, where did I screw up? See, that one asked for, see. There's 3 of those, there's 4 of those. Where did I screw up? Something went wrong up here. Hold on a sec. Wait a minute. 1 calcium, 2 chlorine. All right. 2 sodium, 2 hydrogen, 6 oxygen. Good. All right, so where did I screw up over here? Let's see, 1 calcium. All right, calcium, yeah, okay. 2 chlorine, 2 sodium. All right, 2 hydrogen, and 6 oxygen. Wait a minute. Something's not right here. 1, 2, 2, 2, 6, 1, 2, 2, 2, 6. Yeah. So they all matched up. I don't know why I didn't match up. I don't know. We'll figure it out. All right, filtering the precipitate. Okay, this basically means like if you can filter out the solid particles. All right.
We've studied the reaction between calcium chloride and sodium bicarbonate in detail. We'll now separate the solid that was formed from the other products. We'll do this using a filter. The cup containing the products of the reaction is poured onto a paper towel. This paper towel is suspended over a second plastic cup. The brown paper towel will act as a filter. Liquid will pass through the filter, but most of the solid precipitate will be collected on top of the paper towel.
It's like coffee.
Now let's take a look from a different angle. You can see the water passing through the filter and dripping into the cup at the bottom, while the solid remains on top.
Yep.
Here's an image of the solid after it dries.
Cool. All right. That explains it right there. In the dissolving test, what variables should be kept the same? Select all that should be kept constant for dissolving the test. To be fair, the mass of calcium chloride, carbonates in it, and all being dissolved they should all be about the same amount. Yes. The amount of water used to dissolve each substance. Yes. The temperature of the water. Yes. The method of stirring the substances in the water. Yes. The length of time they're mixed together. Yes. So basically all that together. All right. Let me see if we're right. Yay! All of it. Okay. Mixing calcium chloride, sodium bicarbonate, and the precipitate in water. Let's see.
We've been studying the reaction between calcium chloride and sodium bicarbonate. In the last video, we filtered out the white solid precipitate. We think it's calcium carbonate, but we need to make sure that it wasn't sodium bicarbonate or calcium chloride. In this video, we'll dissolve sodium bicarbonate and calcium chloride and calcium carbonate in water.
So it doesn't react with baking soda. It doesn't react with calcium chloride, but it does react with
The sodium bicarbonate
with
has
calcium.
completely dissolved,
Oh, it does.
and you have a
all
clear,
gone.
colorless solution.
Oh,
Sodium
okay.
bicarbonate is not the precipitate.
It's not
Calcium chloride has mostly dissolved, and the solution is still pretty clear. Calcium chloride is also not the precipitate. The calcium carbonate does not dissolve in water. Therefore, the solid white precipitate is indeed calcium carbonate, the product of the reaction between sodium
So
bicarbonate.
what does
and
it react
calcium
with
chloride.
water? Is what it's asking. All right, cool. All right, which substance of the things is dissolved? The one in the middle. What was the one in the middle? Calcium chloride, the precipitate in the water. All right. Which is the one was the one in the middle? Calcium chloride. Hold on a sec. I'm gonna cheat by not be cheating. Calcium
The
carbonate.
sodium bicarbonate has completely.
All right, that was the one that dissolved. No. That's the one that didn't dissolve. Ah, crajola. So not that one, but the other two, calcium chloride and sodium bicarbonate. Calcium chloride, that one, that's one. Which substance did not dissolve? The calcium carbonate, yes. What does it tell you about whether the precipitate is sodium carbonate, bicarbonate, or calcium chloride, or something different? What does this tell you about whether the precipitate is sodium bicarbonate or calcium? It's something different. It's something different because the other two dissolved in water. All right, cool. What do you think the white solid precipitate is? Here's the reaction we studied. It's the calcium carbonate. All right. The calcium carbonate. Yes. Calcium carbonate. I wonder if I would actually get this one right because it's written the way that it is. I don't know. Check your ideas, see if there is calcium carbonate. That's right. Got that right. All right, so that's chalk. That's good. Boom, boom. All right, now for the last one. Here are the key concepts. Notice that the question said, did you write it in the notebook? Nope, I didn't do it. We got one more minute left. Think of the demonstrations or experiments in this lesson that you found very memorable. Solid form the two. All right, number two. Yep, number two. Number two was pretty cool because the stuff mixed together. Yeah, it's pretty cool. It mixed together, made a different color stuff. Kind of nice. Do I feel confident about it? Yes, I do. Hey, look at that. There's News ELA. So I hit submit. All right. Now what you would do is you go and you would see your accuracy and all that stuff, but we don't have that time, so we're not going to do that. And then, yeah, that's it. So form your precipitate. Turn it in. Boom. Bye-bye.